So we're going to start defining the ports of this particular device, and as you can see here, we have our D, which is going to be the input, enable is another input, clock is another input, reset is another input, and then we have Q, which is an output. And for now, these are all they all have they are all 1 bit. So let's do that. So we have our D, which is going to be an input, and it's an STD logic. And then we have enable, which is also an input, STD logic. And then we have clock, which is also an input, and it's a STD logic. And then we have reset, which is also an input, and it's an STD logic. And then we have Q, which is another input. Sorry, Q is an output. Out, which is STD logic also. Okay. So to just make your program neat, you have to make sure that they all align by having at least one tab, aligning them to your longest name here, and voila, you have it. You have all of them. You have your code now neat. Okay. So after doing that, we would like now to, first of all, we can divide this device into 3 parts. We have our next state logic. So we have our D flip-flop. Okay. Then we have our next state logic, and then we have our output logic. Okay. However, before that, we will need to define our signals here. And if you see all these lines here, these ones are signals, can be defined as signals. So signals are defined in this section, where we have our signals. We can define our signals this way, and we have Q next, which is a one signal, and then we also have Q register, and they are in the form of STD logic also. Okay, so to just make things a bit neat, I usually like to leave space like that, and then now we define the different sections of this particular circuit. So we have our D flip-flop logic, we have our D flip-flop logic, and then we have our next state logic, and then we have our output logic. So now we're going to start with our D flip-flop logic, which you can see here, and this is going to be done inside a process. So we're going to start with the process, and the sensitivity list of this process is going to be our clock and our reset. So it's going to be our clock and reset. So inside our process, because we said that our reset is asynchronous, is asynchronous, which means it does not depend on the clock. We're going to start with it, which we're going to have an if statement that says that if reset is high, or is 1, then what do? Then we say that our next state logic, which is Q register, is going to take 0. Okay. Else if, let me try and make sure that we can see this figure. So else if, now we check if we have a rising edge of the clock. Then what do we say? Then at this stage we assign. Then at this stage we say that our next state logic will be equal to D, which is our current state. So we say this means that Q register is going to take Q next. Okay. Then we're going to end our if and end our process. So now in our next state logic, our output is going to be that Q next is going to be D. It's going to be D when it's going to be D when we have enable being equal to 1, else we take Q register. Okay, so basically this is what is telling us here is that we take Q next. Our Q next is going to be either D when our enable is 1, or we take Q next when our enable is otherwise, which is when our enable is 0. Okay, so our next state logic is going to be that Q is going to be, which is our output, is just going to take the value of Q register. Great. So with that, we have finished our circuit design. And as you can see, if you have your RTL diagram and you've drawn it well, and you'll be able to subdivide it into different parts, it's very easy for you to concentrate on just one part, and knowing your inputs and outputs on that particular part, you will be able to easily write the code for this particular regions. So I'll see you in the next video as we go on to design our test bench in order to test this particular device that we created. So see you in the next video.